Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to see about RFID, Radio Frequency Identification. So this is the famous method we will use for an identification purpose, like an book identification or a person identification or a tag identification. We can use this RFID tags. So this is radio frequency identification methods. So in this we have this ADC, automated data collections. So the technology, it uses the radio frequency waves to transfer the data between a reader and a movable item to identify. To identify or to categorize or to track, we can use this RFIDs. So these can be, for example, if you have a n number of goods in your supermarket, so which goods? So it can be identified by this RFID tags. Similarly, if you go for this library, we have so many books. So each book will be identified with the RFID tags. So identifying that, tracking or categorize, we can use this RFID tags. In a FOSS, it does not require a physical site or a contact between a reader or a scanner, and that will be tagged them. So for example, if you take a barcode, we need to make a contact with the scanner. But for RFID, there is no need of a contact. Simply, it will be automatically, it will be identified when the that is a movable item comes within that particular range. It performs the operation using a low-cost components. It attempts to provide a unique identification and backend integrated with allows for a wide range of applications. Look at this is an example for an RFID tag. Look at this. This is an RFID tag. We have the barcodes and we have this RFID with the microchips. Look at the components of this RFID system. Look at this. This is an RFID tag. So this will carry the mobile items, or we can it will be carried by users. Look at this. We have an antenna. So whenever this RFID tags comes within the particular range, see it automatically detected by this antenna. It transfers that information because we may have so many of RFIDs. So which RFID tag is detected? So that will be given by a decoder. So that way this will be detects and gives that information to RFID reader. So once it identifies this RFID reader, it gives for the network, and then through LAN connection, that is a local area network connection, it will be given for a system to identify it and make a necessary actions. Look at this. This is the sum of the examples for the RFID tags. So tag can be attached to almost anything. Wherever you look at, we can attach the RFID tags. So like an items, cases, plates, we have take a products, high value goods, vehicle, assist, livestock or personals, so many things we can attach the tags. Even if you take an ID cards, so student ID cards, we can use this RFID to track them. So we have two types, one is a passive tags and another one is a active tags. So first we can see these passive tags. So passive tags does not require any powers. So no power should be applied for a passive tags. So it will be draws the power from that field itself. Again, so due to absence of this power, the storage capacity will be very low. So it have a lower storage capacity. So it will be have a few bits to 1 kilobytes. It's a maximum 1 kilobyte data can be stored in that passive tags. So why we need to store means, so to identify that we need to have some unique numbers are different. So that's why we use this memories to store the values. Again, shorter read ranges because there is no power supplies available. So the range of communication will be very less. So it takes from 4 inch to 15 feet maximum possible communications. It will be around 10 times lesser than the active tags. Again, usually write once, read many memories will be used. So we can take some write only one time, read can be done many times. That is an read only memory tags will be used. Cost around less than 25 cents only comes. So 25 cents to few dollars. Look at this another option. This is an active tags. So if we go with the active tags, it is a battery powered. So we need a power supply to operate this tags. So due to this power, we have a higher storage capacity. So this storage comes around 512 kilobytes. Again, longer range it can communicate. So look at this. This is comes around 300 feet communications. 300 into this 30 centimeter. That is 300 feet communication will be possible. Typically, it will be a re-returnable. That is a rewritable RF or things will be used. So these RFID tags can be rewritables. So cost comes from a $50 to $250. it will be cost little higher compared to passive tags, because it will be supplied with the power. Again, we need a higher storage. Again, we need to have a higher range communication capability transmitters. So it will be cost will be high. So RFID tag memories. So this RFID assigned with the factory during manufactures. So can never be changed. So that will be programmed during a manufacturing itself. So no additional data can be assigned to this tags. This is the read only tags. If you take in write once, read many, that means only one time we can write the data. We can read n number of times. So in factory they manufacture memory and they give it us. So once we can write one time data, data can be read many times, but we cannot rewrite the data. So the data written once during the manufacturing or during the user end, but further it cannot be written. So this tag is locked once the data is there. Once if you write the data, it will be locked for the final. Similar to compact disc or a DVD, CD. So these will be examples for the similar concepts. Again, read write tags. These tags can be changed over the time. So we have some data, we can store it. After that, we can modify it to some other values. So this will be both the read and write capability will be available. So part of our all data can be read or write it, or we can lock it for some data. Again, we can write another data. Look at this. We have an RFID reader, we have a computer database, we have this RFID tag, and this is the antenna. So these will be communicates, and the data will be sent to the computer database. So reader function, it's a remotely powered tags, establish a bidirectional data communication between a tag and the devices. So they have the filters, inventory tags, communication with the network servers. So can read 100 to 300 tags per second. Again, readers can be fixed point such as an entrance or exit point, or we can point of sale places. So reader can also movable or a handheld. So the transmitter that will be fixed. So whenever the user comes that places, that will be read and get it. So around 100 to 300 tags can be stored. So for example, if the customer brings 100 product, so within that immediately it can read 100 to 300 tags within the seconds. Thank you.